Hello and welcome to continuity and piecewise functions. So the idea here, as we discussed previously, when we have a piecewise function and we're looking for where it is continuous, not only do we have to look for where the function is undefined, but we also have to look at all the breaks in definition. So to check where a piecewise function is continuous, we need to check for anywhere it is undefined and at any break or change in its definition. For example, let's go ahead and take a look at the piecewise function. F of x equals 2x minus 3 for x less than -2, 3x plus 1 for -2 less than or equal to x less than 1, for at x equals 1 and x squared plus 3 for x greater than 1. So we know that all polynomials are continuous for the whole real number line. So each of these pieces is continuous, at least on its open segment, right? So we know that f is continuous on the intervals from -infinity to -2. We know it's continuous from -2 to 1. And we know it's continuous from 1 to infinity. We know this just off the bat since polynomials are continuous on the real number line, so on R. So the question becomes, what happens at -2 and what happens at 1? So is f continuous at -2 is our first question. So we need to check a couple things. First, does the limit as x approaches -2 exist? And then if it does exist, does it match the function value? So if so, does it equal f of -2? So our function from the left of -2 is 2x minus 3. So if we find the left limit, so the limit as x approaches -2 from the left of f of x is the same thing as taking the limit as x approaches -2 from the left of 2x minus 3. And then that's a polynomial we can go ahead and just plug in. If we plug in a -2 in place of our x, then we wind up getting 2 times -2 minus 3, otherwise known as -7. Now, if we do the same thing coming from the right, the limit as x approaches -2 from the right of f of x. For x just a little bit bigger than -2, we have that f of x is equal to 3x plus 1. So we will now do that this is equal to the limit as x approaches -2 from the right of 3x plus 1. Again, plugging in, we have 3 times -2 plus 1, which is -5. So since these are not equal, the limit does not exist. So these are not equal. So we have that the limit as x approaches -2 of f of x does not exist. You will often see this written as D and E instead. And so we know it's not continuous at -2. So just we'll highlight that. It's not continuous at x equals -2. And now we will ask the same question at x equals 1. So we want to know, is f continuous at x equals 1? So once again, what we need to check is we need to know, does the limit as x approaches 1 of f of x exist? And if so, does it equal f of 1? So we need to check once again. We take the limit as x approaches 1 from the left of f of x. This is the same thing as taking the limit as x approaches 1 from the left up. If we're slightly less than 1, we are in that second row, 3x plus 1. So we are checking the limit as x approaches 1 from the left of 3x plus 1. Plugging in, this becomes 3 times 1 plus 1, otherwise known as 4. Then we check the limit from the right of f of x, and that is equal to the limit coming from the right. If we're bigger than 1 or just a little bigger than 1, our function is defined as x squared plus 3, that last row. So we have that this is equal to x, the limit as x approaches 1 from the right of x squared plus 3. Plugging in, we have 3 times 1 plus 1 squared plus 3. Oops, sorry. It's just 1 squared plus 3. And that winds up being 4. So we have that the limit exists and that the limit as x approaches 1 of f of x is indeed 4. And then the other thing we need to check is this equal to f of 1? So if we take f of 1, we were told that f of 1 was simply equal to 4. So these are equal. So that means that f is continuous at x equals 1. So we have that it's continuous at x equals 1. It's not continuous at x equals -2, and everywhere else it was continuous. So we wind up getting then that f is continuous on from negative infinity to -2, and then from -2 to positive infinity. We don't need to break it once since we're continuous straight through 1. So when we do piecewise functions, other than checking the individual pieces to make sure we don't have any places where it's undefined, then we will check each individual piece or check that where it switches and see, does the limit exist? Do the left and right sides match? And does the limit equal the function value?